What if the cosmos was so exquisitely tuned that even the slightest deviation in its fundamental laws would have rendered it utterly lifeless? Imagine that every atom in the air we breathe, every cell in our bodies, and even the quarks that compose the very building blocks of matter are governed by a set of numbers so precise that if altered by even 1 or 2%, the universe as we know it would not exist. In 1964, the pioneering Soviet astrophysicist Nikolai Kardashev, renowned for devising a method to gauge a civilization's energy use, posed a question that still resonates today. Why does the universe appear so perfectly calibrated for life? For centuries, ancient thinkers such as Pythagoras and Plato gazed up at the heavens, inferring a divine order and attributing cosmic harmony to mystical design. Yet, armed with the precise measurements from ESA's Planck satellite and NASA's Wilkinson microwave anisotropy probe, modern science has shown us that what was once considered poetic perfection is now quantifiable. Fundamental constants. The gravitational constant, which governs how masses attract each other. The speed of light, fixed at roughly 3 times 10 to the 8 meters per second, and the fine structure constant, which determines the strength of electromagnetic interactions, are all locked into extraordinarily narrow ranges. Multiple independent studies have demonstrated that even a slight alteration in these numbers would have led to a chaotic, unstructured universe, where stars and galaxies might never have formed. This astonishing precision, as argued by contemporary theorists like Leonard Susskind, implies that our cosmos is not merely the result of random chance. Instead, it appears as if the universe is the solution to a delicate cosmic equation, one that has been solved just right to permit the emergence of life. As we journey from the realm of subatomic particles to the sprawling majesty of galaxies, we must ask ourselves, is this meticulous calibration evidence of an underlying design, a serendipitous accident, or simply a statistical inevitability among an infinite ensemble of possible universes? Such a question compels us not only to re-examine the nature of the universe, but also to reflect on our own place within this grand cosmic tapestry. Imagine our universe as if it were controlled by a cosmic dimmer switch, where the brightness of existence depends entirely on the precise setting of nature's most basic forces. In our cosmos, the speed of light is fixed at about 300,000 kilometers per second. Newton's gravitational constant is measured at approximately 6.67 times 10 to the minus 11 newtons per square meter per kilogram squared, and the electromagnetic force is roughly 10 to the 36 times stronger than gravity. Rigorous simulations conducted by researchers at MIT and Caltech revealed that even a minuscule change of just 1 or 2% in any of these constants would result in a universe too unstable to sustain even the simplest forms of chemistry, let alone the complex interactions required for life. Historically, the notion of a perfectly ordered cosmos was intertwined with mysticism. Medieval scholars envisioned a universe where Earth occupied the center, surrounded by celestial spheres in harmonious motion. Yet the paradigm shifted dramatically with the revolutionary ideas of Copernicus, followed by Edwin Hubble's discovery of an expanding universe and Georges Lemaitre's proposal of a primeval atom. Today, the existence of the cosmic microwave background radiation, a faint afterglow from the early hot universe, provides irrefutable evidence that our universe began with a Big Bang. From that chaotic moment, order gradually emerged as quantum fluctuations were magnified by cosmic inflation, seeding the formation of stars and galaxies. This fine-tuning is not merely a matter of theoretical abstraction, it is an existential reality. The anthropic principle, first articulated by Brandon Carter and later elaborated by figures such as Sean Carroll, tells us that we observe these precise conditions simply because only in a universe finely tuned in this way could observers like us ever emerge. Yet even this explanation leaves us with pressing questions. Why are these constants so meticulously calibrated, and what would happen if they were ever to vary? Every revelation, from the intricate dance of subatomic particles to the formation of magnificent galaxies, underscores the fragile balance upon which our very existence depends. This delicate equilibrium forces us to confront the profound mystery at the heart of our cosmos, a mystery that demands both rigorous scientific inquiry and deep philosophical introspection. By integrating precise measurements, historical evolution, and the inherent mystery of the universe's design, these first two chapters set the stage for a journey that spans the tiniest particles to the grandest celestial structures, inviting us to question the very nature of existence and our role within it. Now, let us consider a profound framework that challenges our very understanding of why the universe appears so perfectly tuned. The anthropic principle posits that we observe these exact life-permitting conditions because only in a universe with such precise constants could observers like ourselves arise. In its weak form, it reminds us that our presence necessitates a universe where the physical laws are just right. In its strong form, it even suggests that the universe is somehow compelled to develop conditions favorable to life. Renowned figures such as Brandon Carter, who first articulated these ideas in the 1970s, and contemporary cosmologists like Sean Carroll have debated these interpretations at length. Imagine, if you will, that our universe is but one in an almost infinite ensemble, a vast multiverse, where each universe is governed by its own unique set of constants and laws. In such a cosmic lottery, it is not surprising that one universe would by chance have the precise calibration necessary for life. Advances in cosmic inflation theory and the string theory landscape hint at this possibility, suggesting that our finely tuned cosmos might be the inevitable statistical outcome amid countless possibilities. Yet, despite the elegance of this idea, conclusive evidence remains elusive, leaving us with an enduring mystery. Is the exquisite precision of our universe merely a consequence of our observational bias, or does it point to a deeper, perhaps even intentional order? This question challenges us to rethink not only the nature of the cosmos, but also our role within it, as both products and witnesses of its remarkable design. From the chaotic crucible of the Big Bang to the breathtaking order of spiral galaxies and luminous nebulae, the story of our cosmos is one of transformation from disorder to harmony. In the immediate aftermath of the Big Bang, the universe was an almost featureless, seething expanse of energy and particles, a state of sheer chaos where structure was non-existent. Yet through the process of cosmic inflation, tiny quantum fluctuations were dramatically amplified, seeding the formation of all subsequent structures. Observations from the Hubble Space Telescope and data from the Planck satellite have shown that these minute irregularities eventually coalesced into stars, galaxies, and clusters, weaving an intricate cosmic web. This emergence of order is not simply a consequence of gravitational clumping, it is a wondrous instance of self-organization, where simple physical laws give rise to complexity far greater than the sum of their parts. It is much like watching the chaotic dance of water molecules suddenly organize into the exquisite symmetry of a snowflake, or the branching of a tree emerging from the interplay of countless individual cells. Recent breakthroughs in dark matter research further illuminate how unseen forces act as a scaffolding for the visible matter, maintaining a delicate balance between gravitational collapse and the expansive push of dark energy. Yet even as order blossoms from chaos, there remains a constant tension, a reminder that the very forces which create this cosmic harmony could, if unbalanced, lead to collapse and entropy. This dynamic interplay between order and disorder, between precise calibration and inherent unpredictability, not only deepens our appreciation of the universe's origins, but also compels us to confront the fragility of all existence. As we trace the journey from the fiery birth of the cosmos to the structured grandeur of galaxies, we are left to ponder. How did such intricate complexity emerge from a formless beginning? And what does that profound transformation reveal about the nature of reality itself? As we stand in awe of a universe so finely tuned that even the smallest deviation in its fundamental constants would have rendered it barren, we are forced to confront the profound implications for our own existence. If the speed of light, the gravitational constant, and the forces that bind matter are all calibrated with such extraordinary precision, then our presence is not merely a cosmic accident, but a rare, almost miraculous outcome. Esteemed voices like Martin Rees, the astronomer royal, and philosopher Nick Bostrom remind us that this delicate equilibrium comes with immense responsibility. Our technological advances, environmental stewardship, and social progress all mirror the intricate balance that sustains the cosmos. Yet history is replete with great civilizations that collapsed when their internal equilibrium was disrupted. Today we face existential threats: nuclear conflict, climate disruption, and the peril of runaway artificial intelligence, that serve as stark reminders that our future is as fragile as the finely tuned universe that permits our existence. In understanding this cosmic balance, we recognize that our quest for knowledge and progress is inextricably linked to our duty to preserve the conditions that allow life to flourish. It is an urgent call to reevaluate our choices and align our ambitions with the very order that governs the stars. After traversing the vast spectrum from subatomic particles to the majestic orchestration of galaxies, we arrive at a question that lingers at the very edge of human thought. Is the perfection of the cosmos the result of deliberate design, a wondrous accident, or the inevitable outcome of deeper, as yet undiscovered laws? Our exploration has revealed a universe in which every physical constant is set within an almost impossible narrow margin, where the chaotic aftermath of the Big Bang has been sculpted into the harmonious structures we now observe. Yet this impressive precision forces us to confront our own place in the grand scheme of things. We are not merely passive recipients of a fortunate cosmic lottery. We are active custodians of an exquisitely balanced system. The insights gained from the anthropic principle, the possibility of a multiverse, and the emergent order from primordial chaos all serve to remind us that our destiny is intertwined with the fundamental fabric of reality. As we reflect on the cosmic design, we are left with a challenge to harness our scientific, technological, and ethical capabilities to ensure that this fragile balance endures. In the end, the mystery remains unresolved, a challenge to be pondered by every thoughtful observer. Will we rise to our cosmic potential, or will we succumb under the weight of our ambitions? The journey continues, and the quest for understanding these unseen truths beckons us ever onward.